Okay guys, today we are going to show that if the greatest common divisor of a and b is c, then the greatest common divisor of a square and b square equal to c square. Now let's get started. So we have to let a and b be integers. So we gotta let a and b be integers such that a is not 0 or b is not 0. And from this problem, we have to assume that the greatest common divisor of a and b is c, okay? And try to show that the greatest common divisor of a square and b square is c square. It's like if you have the greatest common divisor of two numbers a and b equal to c, when you square both numbers, the greatest common divisor turns out to be the square of the greatest common divisor of those two numbers. Now let's start with this. So I have to show that c square divide a square and b square. So first we're going to show that d square divide the greatest common divisor of a square and b square. And then try to show that the greatest common divisor of a square and b square divide c square. And we're going to try to show that. First we try to show that c square divide a square and b square. Okay? Divide the greatest common divisor of a square and b square. And then what do we have next? We start with the greatest common divisor of a and b, which is c. Then what do we have right here? Since c is the greatest common divisor of a and b, that means that c divide a and b, right? C divide a and c divide b. What does it mean by this? By divisibility, there exists integers q1 and q2 such that a equal to qc, okay, and b is q2c. All right, and then we square both sides of this equation. What do we have? We gotta have a square equal to q1 square c square, okay? And we gonna have b square equal to q1 square c square. All right? Then, since q1 square and q2 square are integers, what do we have? We gonna have c square divide a square and c square divide b square. So that means that a square divide c square divide a square and c square divide c square. Then what do we have next? When c square divide both a square and b square, that means that what do we have? So remember, if you have c divide a and c divide b, we can say that c divide the greatest common divisor of a and b. So c square must divide the greatest common divisor of a square and b square. That's it. Okay, so we have proved that c square divide the greatest common divisor of a square and b square. Now let's show that. The greatest common divisor of a square and b square divide c square. Okay, what can we do right now? So the next thing we're going to do is to take a look at the greatest common divisor of A and B, which is C. Okay, so since the greatest common divisor of A and B is C, what do we have? So we're gonna have Basel identities, right? So they exist integers x and y such that ax plus by equal c. Okay, this is the Basel identities, and we are going to have this one, and I want to raise to the power of 3. Okay, so that means that we're gonna have ax plus by times ax plus by raised to the power of 2. So we're gonna have c cubed, right? That means that we have c times c squared. And expand each term. Expand these terms. What do we have? We're gonna have ax plus by times a squared x squared plus 2abxy plus b squared y squared equal to c cubed. Okay. Then what do we have next? We distribute ax into each term. So what do we have? We're gonna have a cubed x cubed plus 2a squared bx squared y plus a b squared x y squared. And distribute by into these 3 terms. So we're gonna have a squared bx squared y plus 2ab squared xy squared plus b cubed y cubed equal to c cubed. Then what next? Next thing we're going to do is to let the term with a square be next to each other. So we're gonna have a cubed x cubed plus 2a squared bx squared y plus a squared bx squared y plus ab squared xy squared plus 2ab squared xy squared plus b cubed y cubed. Okay, great. Equal to c cubed. All right. And this term has a square as common factors. So we're gonna have a square times ax cubed plus 2bx squared y plus b x squared y and plus. So these 3 terms has b squared as common factors. So we're gonna have b squared axy squared plus 2axy squared plus by cubed equal c cubed. Okay, great. So this is equation A. Okay, equation A. And then what next? Next thing I'm going to do is to take a look at this greatest common divisor. So since the greatest common divisor of A and B is C, what do we have? That means that C divide A and C divide B. Okay. Then what do we have? By divisibility, we're gonna have Q1, Q2 being integers such that A equal to A1C and B equal to Q2C. Okay. Then what happened to equation A? So equation A becomes, what does it becomes? It becomes a square, okay, and A becomes Q1C x cubed plus 2q2, right? B is q2c, okay? X square y. B is q2c x square y. Plus b square, what is A? A is q1c. q1c x y square plus 2q1c x y square. And B is q2c y q equal to c square. Now all these terms have c as a factor. So we're gonna have a square c, okay, a square c, q1 x cubed plus 2q2 x square y plus q2 x square y plus b square c q1 x y square plus 2 q1 x y square plus q2 y cube equal to c cube. If we divide both sides by c, then what happens? Okay, dividing both sides by c. What do we have? What do we have is, well, this c will be cancelled, right? So it turns out to be a square q1 x cubed plus 2q2 x square y plus q2 x square y. Oh, okay. And then what next? Well, we're gonna have b square q1 xy square plus, okay, 2q1 xy square plus q2y cube equal to c square. Okay, great. What next? So I will call it equation B. And now let's go back to, let's take a look at, if you have, okay, let me say this. If you have the greatest common divisor of A and B, what do we have? We can say that the greatest common divisor of A and B divide A, right? And the greatest common divisor of A and B divide B. Okay? Now, by this fact, we're going to use this. Since the greatest common divisor of A and A square and B square divide A square, and the greatest common divisor of A square and B square divide B square. Alright? Then what do we have? So for all integers x1, x2, what do we have? We're gonna have the greatest common divisor of A square, B square divide A square x1 plus B square x2. Okay? Then what do we have next? So we take a look at these numbers. These are integers, right? Okay? So since this term right here, and this one, this is also integer. This one right here, let me copy this. These are integer. And we have this equation. Okay? We have this equation right here. So what do we have? These are integers. And we have a squared times integer plus b squared times integer equals c. So that means that we can plug in, we can have the greatest common divisor of a squared and b squared divide this term, right? Okay? So we can have, Okay, let me write like this. We have the greatest common divisor of A and B divide this term right here, like this. How can we write this? Because we have, for all integers x1, x2, we have the greatest common divisor of a squared and b squared divide a squared x1 plus b squared x2, and these are, okay, these numbers are integers. These numbers are integers. And this integer is with a square. This integer is with b square. So we can have the greatest common divisor of a square and b square divide this term. Okay? Or we can say that the greatest common divisor of a square and b square divide c square. Okay, great. Now we have the greatest common divisor of a square and b square divide c square, and c square divide the greatest common divisor of a square and b square. So what do we have? Since, okay, c square divide the greatest common divisor of a square and b square, and the greatest common divisor of a square and b square divide c square. What do we have? We're gonna have the greatest common divisor of a square and b square equal to c. Okay, that's it. So we have shown that if the greatest common divisor of a and b is c, then the greatest common divisor of a square and b square equal to c square. Okay, and that's it for this video.